This is lesson 11.4, Areas of Regular Polygons and Composite Figures. Your objectives are to find the areas of regular polygons and find areas of composite figures. Find the area of each regular polygon. Round to the nearest tenth. For a regular polygon, the area is equal to half the perimeter times the apothem. For a triangle, we know one side is 14, so the perimeter is going to be 14 times 3, which is 42. And then for the apothem, I can use my apothem chart using apothem equals side over 2 times the tangent of 30 degrees. I got that from my apothem chart. A side length is 14. So 14 over 2 times the tangent of 30. Which is about 4.04. So for the apothem, I'll put 4.04. When I substitute that all in, I get 84.9, and that's centimeters squared. So remember, when you need the apothem, use your apothem chart, substituting in a side length and using the appropriate angle for tangent. Number 2 is a regular pentagon. Area equals half perimeter times apothem. I don't know the perimeter, but I can find a side length if I use my apothem chart to get the measure of a side equals 2 times the apothem over the tangent of 54 degrees. 54 degrees is because it's a pentagon. So 2 times the apothem here is 7, divided by the tangent of 54 degrees is about 10.17. So if one side is 10.17, multiply by 5 to get about 50.85 for the perimeter. So I'll substitute that in, 50.85, and the apothem is 7, making for a grand total of about 178.0 meters squared. So when you know the apothem, use your apothem chart to find one of the side lengths, 2a over tangent 54 degrees. Since there's 5 sides, multiply the side length by 5 to get the perimeter, and use the apothem. Find the area of each figure. Round to the nearest tenth if necessary. For this composite figure, we need to look at it and determine what type of shapes it's divided into. Since I have a curve over here, I can see that it should be divided right about there into a semicircle. And there's also a congruent semicircle cut out of this side. So what I can do, imagine taking this semicircle, cutting it out, and replacing it over here. So essentially, what I have then, instead of this type of figure, really, I have, when that semicircle is put in there, I have a square that's 20 by 20. For a square, the formula is s squared. A side length here is 20, and 20 squared is 400, and that will be millimeters squared. So since I was able to take the one piece and slide it into the other slot, really what I have is a square. For number 6, I have a composite figure that I'll just divide into different shapes and add up the areas of each one. Well, I see the curve over here, which means I'm going to have a semicircle, which I can divide. And I also have a piece over on the left and a piece in the middle that I can see will be divided right there. So really what I have is a square, plus in the middle I have a trapezoid, and on the right I have a semicircle. So I can add up the areas of each one. The formula for the area of a square is s squared. The formula for a trapezoid is half height times the sum of the bases. And the formula for a semicircle is half pi r squared. Let's substitute the values in now. A side of the square is 13, so 13 squared. For the trapezoid, the height of the trapezoid is right there, that's 20. The bases of the trapezoid, that one's 13, and that one's 30. And the radius of the semicircle, it has a diameter of 30, so the radius will be 15. I'll punch all that in. (952.4), and that will be inches squared. So determine what shapes you have. Use the area formula for each shape, substitute the values in, and add them all together.